sometimes with the shape, you're not looking for the volume, as in everything inside that shape. You're looking for the surface area, and that's what this video is going to be about. Surface areas. Surface area. Let's switch up the font to something like that. There we go, surface area. If we have a shape like so, that would be a triangular prism. Triangular because it's made up of a triangle repeated again and again and again all the way, and a prism because it's 3D. So that's a triangular prism. And if you're asked for the surface area, that's different from being asked for the volume. They don't want you to tell them how much can you fit inside that. If it was some sort of jug, how much water could you fit inside? That's not what they're asking. They're asking for if you made it into some sort of net, if you cut it up and put it on a piece of paper, how big would the area be of that entire shape? Let's show you what I'm talking about. This triangular prism has a height of 4 centimeters, a width of 3 centimeters, a diagonal of 5 centimeters, and a length of, let's say, 10 centimeters. And we want to find the surface area of this shape. The first step in finding the surface area of a shape is to find how many surfaces has it got. Because the only way to find the surface area is to work out the area of each of the surfaces and add them all up. How many surfaces has this shape got? Well, I can see one triangle on the left and another triangle on the right, that's 2. I can see a floor down here, that's 3. I can see a back up here, that's 4 surfaces. And finally I can see a front along here, that's 5 surfaces. So it's got 5 surfaces. Let's do them one by one. How about this triangle on the left here? How do we find the area of a triangle again? We do base times by height and then divided by 2. Base times by height divided by 2. I see so many students forgetting to divide by 2 when finding the surface area of a triangular prism, because they forget that the area of a triangle, you don't just do base times by height, but you do base times by height and then divide by 2. Okay, in this case, 3 times by 4 is 12, and 12 divided by 2 is 6. So the area of that triangle on the side is 6 centimeters squared. Whoops-a-daisy. 6 centimeters squared. Oh dear, no squared. Anyway, I'll just draw it on. Can you guess what the area of the triangle on the right is? Well, it has a height of 4 again, and a base of 3. So, same thing. 6 centimeters squared again for that triangle. You may be wondering, what about that 5 along the hypotenuse? Doesn't that make a difference? Not to the area of a triangle. In the area of a triangle, you don't do base times by height, add the diagonal, or times by the diagonal. You ignore that, really, and you do base times by height divided by 2. Okay, let's do the floor of this triangular prism. That would be 3 times by 10. Often the challenge really is to see which side you're dealing with. So in this case, it would be 3 times by 10. 3 times by 10 is of course 30. So that would be 30 centimeters squared. What surface should we do next? We've done 2 of them. Let's do the back. The back is this side back here. Can you see which 2 sides we're going to multiply? It would be 4 here times by 10 along here. 4 times by 10. 4 times by 10 is indeed 40. So that's 40 centimeters squared. Last surface. Can you see which one? Yeah, it's going to be that front surface along here. So this front surface down here. There we go. Now that's going to be 10 along here multiplied by 5 along here. Always think carefully about which side you're going to multiply. 5 times by 10 is 50, so that's 50 centimeters squared. Our last challenge now is to add up all of those different surfaces to get the total surface area. 6 plus 6 plus 30 plus 40 plus 50, 50 equals, let's put it down here, equals 12 plus 30, 42, plus 40, 82, plus 50, 132. So 132 centimeters squared. Right, let's do one more shape. I'll draw it in front of you this time. So that would be, we're going to do a cuboid. There's one side, and there's another side, like so. Then we need to join them up. That was a bit too long. And let's make up some of the lengths of the sides. What length should we call it? Let's call all of these side bits as 2 centimeters. So that's 2 centimeters, and therefore that's 2 centimeters. And the long bit, let's call 8 centimeters. Remember, with surface area, the first challenge is how many surfaces. I can count 1 at the front, 1 at the back, that's 2, a square on the left, a square on the right, so that's 4 in total, and a ceiling and a floor, so that's 6 surfaces. The squares on the left and right are 2 times 2, which is 4. So it's 4 on the left and 4 on the right, over here. Now the floor is going to be 8 times 2, which is 16. And the ceiling is going to be 8 times 2, which is 16. And the front also is 2 tall and 8 across. Let's write that on. 2 tall, if you think about it, and 8 across. So that is also going to be 16. And the back is 2 tall and 8 across, which is going to be 16 as well. In total, we'd have 4 plus 4 plus 16 plus 16 plus 16 plus 16. 16 times 4 is 64, plus 4 is 68, plus 4 is 72. So all of that adds up to 72 centimeters squared, and that is how you find the surface area of 3D shapes.